All right, so we have talked about systems of linear equations, how to set up problems with them, how to solve them using three different methods, either graphing or two algebra methods, substitution or elimination. The last thing I want to talk about is just some special cases when we solve systems of equations. Okay? Because all the solutions or all the problems we've solved and all the questions we've done have had one solution. It's possible that you may get more than one solution or no solutions, right? Depending on the system. So I want to look at three situations. So let's look at this system. 2x plus y equals -4, y equals x minus 1. And we're going to solve this by graphing. So I'm going to do this one in purple. Whoa, what is that? Gray? Oh yeah. Let's try that again. Whoa. What the heck? Stop it. This thing's getting out of control. Still out of control. What's going on? Be nice. Okay, I think we got it. All right, whoops. Went ahead of page. There we go. This is what we want. Ay, ay, ay. Okay. Purple. There we go. All right. So remember, we've learned three different ways to graph. If it's in a certain form, slope-intercept is usually the quickest way to graph. This purple one is, what's the number in front? We just don't write it? 1. So this is in the form y equals mx plus b. What's the y-intercept? -1. What's the slope as a fraction, rise over run? 1 over 1. So we plot the y-intercept, -1, and from the y-intercept, remember, not from the origin, from the y-intercept, we rise 1 and run 1. So we get this line. Okay. This one, not quite in y-intercept form, but I only have to do one thing to get it into y-intercept form, and that's to swing the 2x over to the other side by subtracting 2x. So I get y is equal to -2x minus 4. That's in slope-intercept form. So the y-intercept of this, just like we did with the previous one, similarly, is -4. The slope is -2 over 1. So we plot the y-intercept of -4. From the y-intercept, we go down 2, because it's negative, to the right 1, and we get this. Okay. I'm not so worried about what the solution is, but how many are there? How many times do these two lines intersect? Just once. So we would just say that there's one solution. Okay. You can get the actual solution. It's -1, -2. But all I'm concerned about now is just how many solutions there are. Look at these two equations in slope-intercept form. Are the slopes the same or different? Different, right? Whenever we have different slopes, okay, the lines are going to go at different angles. So they'll cross each other once. Those are the types we've been solving. So when two lines have different slopes, there will always be one solution to the system. Doesn't even matter what the y-intercepts are. If slopes are different, they're only going to intersect each other once. But that doesn't happen all the time, even though it's happened all the time, all the questions we've done so far. So let's look at another one. Here, I've given you the same first equation, but I've given you a different second equation. This one on the right is already in slope-intercept form. Its y-intercept is 3. Its slope is -2/1 as a fraction, meaning rise -2, go down -2, and then go to the right 1. So we plot our intercept of 3, y-intercept, go down 2 to the right 1, and there's our line. It will look something like that. This one we already did on the previous page. Remember, we changed it to this. And the y-intercept was -4. And the slope was -2/1. We already graphed this one on the previous page. So this is really nothing new. But that's what the system looks like. How many times are they going to intersect? Never, right? So in this situation, there would be no solution. There's no answer to the system. Look at both equations in slope-intercept form. What do you notice? What's the same? The what? They're parallel, right? Why? Because they have the same slopes, exactly. Okay? So if they have the same slopes, but the y-intercepts have to be different, that means they're never going to intersect each other. So there's going to be no solution to the system. So from that, we can make the conclusion that when the slopes of two lines are the same, meaning they're parallel, like somebody said, but the y-intercepts are different. That's important. The y-intercepts have to be different. There will always be no solution to the system. There will always be no solution to the system. So we've talked about when they have different slopes, they'll intersect each other once. We talked about when they have the same slopes but different y-intercepts. They'll never intersect each other, which means there's no solution, which means there's a third way. This example, this is the same equation from the previous one, where the y-intercept is 3 and the slope is -2 as a fraction over 1, rise over run. So the y-intercept we plot, from the y-intercept we go down 2 to the right 1, and we get our line. We already did that one on the previous page. This one on the right is different. We're going to have to do some algebra to get y by itself. Because right now we've got a 4x with the 2y on the left, and we've got a times 2 right beside the y. What do I get rid of first, the 4x or the times 2? The 4x. Always get rid of what's furthest away from the y. So I'm going to swing this over to this side by subtracting 4x. So that'll get rid of those. And I end up with 2y equals, and I'm going to write the x, the -4x first, because I want slope-intercept form, plus 6. Now I got to get rid of the times 2 by dividing everything by 2. And I get y equals -2x plus 3, which happens to be the exact same line as the one on the right, the purple one. The y-intercept is 3. The slope is -2 over 1. It's the exact same as this one. So the blue one goes right on top of the purple one. How many solutions are there? Think about it. How many times do they intersect if they're the exact same line? Infinite. They constantly intersect each other because one's on top of the other. So infinite solutions. So what happens in that case when the two lines or equations are identical? So when the two slopes and two y-intercepts are the same, there are always infinite solutions to the system. So 3 situations. Slopes are different, automatically 1. But if the slopes are the same, 2 things happen. If the slopes are the same and the y-intercepts are different, they run parallel, they never intersect, no solution. If the slopes are the same and the y-intercepts are the same line, infinite solutions. 3 cases. So let's look at a couple of examples. Here you're given 3 pairs or 3 systems, and you're asked to find how many solutions there are. Okay? Well, we saw when we did the three, that if we put them all in slope-intercept form, we can compare their slopes and y-intercepts. So what we need to do in all of these cases is put the equations in slope-intercept form, or y equals mx plus b form. So we're going to have to do some algebra. So for the first one, A, we've got x plus y is equal to -2, and we've got -2x minus 2y is equal to 4. First one, I can get into y equals mx plus b form pretty quickly by doing what? Subtracting x. So I get y by itself on the left, and on the right, it will be -x minus 2. Or -1x minus 2, you can think of it. Second one, I got to do a little bit of work too. First step, add 2x to both sides to get the -2x over to the right. So I get -2y equals 2x plus 4. And then divided by -2. Remember, if you're dividing to get the variable by itself, it's got to be the exact same thing as what's being multiplied. And you get y is equal to -x, or -1x, minus 2. What do you notice about the equations? Same. How many solutions? Infinite solutions. Infinite solutions. Same slopes and y-intercepts. So for B, I'm just going to take these out so I don't have to keep scrolling up and down. So for B, we've got the equations 4x plus 6y equals -10. And -2x minus y equals -1. So I'm going to have to do some work to both of them. So just like we've been doing, get the x over first, in this case by subtracting 4x. And my equation now looks like 6y equals -4x minus 10. Got to get rid of the times 6 by dividing everything by 6. So that goes, what is -4 divided 6? -2/3. Leave it. Can't divide it cleanly. Leave it, but reduce it. And how about -10/6? -5/3. If I were a betting man, I think we're going to end up with different slopes because I don't think we're going to get any fractions for the second one. Swing the -2x over by adding 2x. Don't forget, there's still a negative in front of that y. Equals 2x minus 1. And how do we just, when we want to change this to positive, what do we do to everything else? Right, or just change the signs on everything. That's the same thing. How many solutions? 0? 1. Why? Yeah. Doesn't matter. The y, in this case, the y-intercepts don't even matter. They have different slopes. As soon as they have different slopes, that means they're angled differently. And as soon as you get two lines that are angled differently on a grid, they got to cross each other somewhere. Because the other two situations is they're parallel or one's right on top of the other. So finally for C, we've got the equations 3x plus y is equal to -1. That should be pretty straightforward to change to slope-intercept form. And we've got -6x minus 2y is equal to 12. What do I do to get slope-intercept form in this first one? Subtract 3x from both sides. So I end up with y is equal to -3x minus 1. That's done. Here, add 6x to both sides to move it over. So I get -2y is equal to 6x plus 12. And then divide everything by -2. And we get y is equal to 6 divide -2, which is -3x, plus 12 divide -2, which is -6. How many solutions? None. No solutions. Because the slopes are the same. But, and this is important, the y-intercepts are different. That means they run in the same direction, never meet. So they can't intersect, therefore there's no solution. Okay. So that's one type of question you could see, where I give you a system and say, tell me how many solutions there are to it. You don't have to solve it, you just have to tell me how many solutions there are. Another type of question would be like this. I give you one of the equations in the system, okay? And I ask you to tell me the second equation so that the number of solutions is either going to be 1, none, or infinite. What do you want to do with this first? Yeah, put it in slope-intercept form by adding 2x to both sides. So we get y is equal to positive 2x plus 4. So that's the first equation in the system. The second equation, you've got choices here. How would you have to write the second equation so that there would only be one solution? The slopes would have to be different. Okay? So all you have to do, and you've got infinite numbers to choose from, is pick a different number than 2. So y equals 3x. And you can keep the y-intercept the same if you want, or you can change it. Because remember, when there's one solution, the y-intercepts don't matter. Okay, so, or I could have done, y equals 3x and then change the y-intercept. Change it to plus 5. But there's numerous answers. How would you write the second equation so that there's no solution to the system? Same slope. So y equals 2x But then what? The y-intercepts have to be different, so you have to pick a different number than +4. So you want to go +5. And finally, infinite solutions, well, they have to be the exact same line. So just write the exact same equation. That's all. Okay. Okay, so that takes care of systems.